One-dimensional motion review. Common terms that we can use to describe motion. Scalar quantities and vector quantities. Scalar quantities. Examples could be mass, measured in kilograms, time, measured in seconds, distance, measured in meters. In the past, you may have used grams to measure mass, or hours, or weeks, or days to measure time, maybe miles to measure distance. While those are all acceptable terms, these are the terms that we use as a standard for physics. Something that these things have in common is that all of these values cannot be negative. If I had a negative amount of mass, I wouldn't exist. If I had negative time, I'd be moving backwards in time. Those are easy ways that I like to remember them. So scalar quantities must be positive. They do not have a direction component. The difference between something that has a direction and does not have a direction is when it has a direction, it's considered a vector. It can be positive or negative. Distance is something that we refer to as only being positive. If we say that something moves backwards or in a negative direction, then we're applying that direction and it needs a different name. Displacement. Still measured in meters, just having that direction. In terms of the equation, we see distance with the letter D, and displacement is typically the change in distance. I can do my change in distance by figuring out what I'm doing to be different. If I move forward and pause and move forward some more, then my change would come from adding those two distances. If I move forward, paused, and then move backward, then I need to subtract those distances from one another to find my change. If I move forward and then turned and walked in a different direction, well, now I have motion along the x-axis and motion along the y-axis. My change would come from knowing the difference in those two. I've got a triangle going here, so my change would be using Pythagorean theorem, that x squared plus my y squared equals c squared. So if I take the square root, I get just the displacement that I need. Other common terms that we use: speed versus velocity. Both are going to be represented by the letter v in an equation. Speed is typically going to be measured where we're using the total distance divided by time, whereas velocity is going to be the displacement divided by time. Even though they're both represented by the letter v in an equation, they also have the same units, meters per second. So I'm getting meters from the distance divided by seconds from the time. The last common term that we'll use in terms of motion is acceleration. Acceleration is going to come from doing the change in the velocity divided by time. My change in velocity. I can change my velocity by changing my speed, or because velocity has direction, I can turn. Both would show some type of acceleration. Because my velocity is meters per second, and I'm dividing by seconds again, the units for acceleration are meters per second squared. If you can know the units, this really helps to be able to do the math that we need to determine how an object is moving. So if I can recognize the meters, seconds, meters per second, and meters per second squared, it'll help me to figure out what equation to use and plug the values into their appropriate locations. So meters, seconds, meters per second. Plug them in, and then use some algebra to solve values. You should be able to rearrange the equations by doing basic algebra steps. As an example, if I wanted to solve my speed equation for distance, then I would start with my initial equation. I'm going to do the inverse of dividing by t is to multiply by t. This side they cancel, and on this side I'd be left with velocity times time. I could continue to rework it if I needed to solve for the time. I could do the inverse of multiplying by the velocity is to divide by the velocity. So distance divided by the velocity would give me my time. 3 different ways to write the same equation. Same thing could go for my velocity equation because it's the same equation. And my acceleration equation looks pretty similar. Now, acceleration equation is often written as final velocity minus initial velocity over time. So we could have an extra step if I needed to solve that one. Again, the inverse of dividing by t, multiply. The inverse of subtracting the initial velocity is to add the initial velocity. And I could rearrange from there. The other major skill that you need to remember for one-dimensional motion is how to graph that motion. So to graph that motion, I can graph an object's speed, velocity. I can graph its acceleration. And I can also tell its displacement, depending on the type of graph that we have. I say velocity and not speed, because from a graph, we should be able to decide the direction. If it's positive, then we know that it's moving forward. If it's negative, we know that it's moving back. Could also move up for positive and down for negative. But because I can look at a graph and determine the direction, we see velocity, not speed, to be most precise. To determine the velocity that an object has, we might have 2 different types of graphs to look at. On a distance time graph, the velocity will be represented by finding the slope of the line. If the line is steep, I'm moving fast. And if the line is shallow, I'd be slow. We could be given a velocity time graph, in which case I just have to read the graph. I can find a spot at a given time and figure out what my velocity is. For the displacement, if I have a distance versus time graph, I can find the spot at a given time and figure out what that value is. To determine the acceleration of something, I would look at the velocity versus time graph, and again I'd find the slope, because acceleration is velocity divided by time, rise over run. If I have that same graph, I could do velocity times time, and that would give me my displacement. So if I found the area underneath that curve as opposed to the slope, I'd have my displacement. Some examples of graphing. Let's start out with looking at the velocity. If you were in a car driving along and you approached a turn, your car, in order to avoid flipping, would need to slow down as you approach that turn. Once you hit about the midpoint, you would want to accelerate or speed up through the turn. This is a good representation of a displacement versus time graph. I can see that I'm slowing down as I move away in the positive direction, and then I can speed up as I move back in the negative direction. If I wanted to take this graph and put it onto a velocity time graph, I can again see that I'm moving and I'm slowing down as I go away. So I'm moving away. I'm positive. I'm going to be in this positive section. I'm going to slow down. I'm going from fast to the slowest I can be, to stopped. I'm going to move towards that line. As I leave the turn, I'm going backwards. I'm going to be in this negative section, and I'm accelerating, I'm speeding up. So I'm going to go back to being fast, just in the other direction. So my line would continue like this. This shows two of the different ways that we can change our speed. Another good example that you can use to remember is think about a hill. If you were to try to run up the hill, and as you ran up that hill, you're going to be pretty slow. And as you roll down the hill, you would be pretty fast. So 2 ways to think of that graph. The other distance time graph that encompasses different motions would be this U-shaped graph. Here, I can again think of myself in that car. I'm going to slow down as I go towards it, and I'm going to accelerate through. So I'm going to slow down as I come backwards this time, and I'm going to accelerate as I go forwards away. So here's my distance time graph again. For my velocity time graph, again, I can be fast in the forward direction, I can stop, or I can move in the negative direction and still be moving pretty fast. So if I wanted to graph this one, my negative slope puts me in the negative direction. I'm going to start fast and get slow. So I'm starting fast and getting slow. Once I reach that midpoint, I'm going to move in the other direction, so I'm now in the positive direction, moving away, and I'm going to accelerate through that turn. So between this graph and this graph, we have 4 different methods that we can have motion.